Hello friends, welcome to engineering tutorial. So we will resume our discussion on waves and oscillations. Okay, in the next series of videos we'll be discussing various concepts related to waves and oscillations. So if you look back at the waves and oscillations playlist, we covered the theoretical derivation part of simple harmonic motion. Okay, various concepts, various examples, real life situations related to simple harmonic motion. So in the next series of videos we'll be discussing some questions, some problems on SHM, simple harmonic motion. So this is the first question. It is given that a simple harmonic motion, it is represented by the equation x is equal to 0.34 cos 3000 t plus 0.74, where x and t are in millimeter and seconds respectively. We have to determine the amplitude, the frequency and the angular frequency and the time period of this SHM motion. So if you remember, simple harmonic equation, simple harmonic motion equation, its standard form is given by x or y, whatever you want to write. X is equal to a sine omega t plus phi, or x is equal to a cos omega t plus phi. In some books or other places you will find y is equal to a sin omega t plus phi, or y is equal to a cos omega t plus phi, as long as it is sinusoidal form. Here it is represented in cos form. Okay, the given equation is, the given SHM equation is x is equal to 0.34 cos 3000 t plus 0.74. So here in this SH equation, all these parameters, they represent some important information associated with it. Here this a part is called as the amplitude. Okay, the maximum displacement of the particle undergoing SHM from the mean position. This omega is called as the angular frequency. This t is the time instant, particular time instant, and this phi is the initial phase at time t equals to 0, whether it is leading or lagging, okay, that particle in terms of SHM motion. So here if we compare these two equations, because it is given in cos, so we'll be comparing these two equations. So if we compare them, we will find a is equal to 0.34, which is the amplitude. 0.34, it is in how much? Millimeters. 0.34 millimeters. Okay, that is the amplitude. Then we have 3000 t, okay, which is, if we compare it, it is omega, angular frequency, that is 3000 radians per second. That is the angular frequency. Now we know that angular frequency and frequency, they are related as omega is equal to 2 pi f. That implies f is equal to omega by 2 pi second inverse or hertz, whatever you want to write. So here it will be how much? Omega is 3000, so it will be f is equal to 3000 by 2 pi. Okay, you can keep it in this form, or you can find out its decimal equivalent, which will be 1500 by pi, and it is coming around, it will come somewhere above 450. If it would have been 3, it would have been 500, but it is 3.14. So but let us calculate. It is coming around yes, 477.707 hertz or second inverse. Okay, now time period, that is equal to reciprocal of frequency. Okay, so that is equal to 1 by 477.707, that is coming around, if we round it off, it is coming around 0.002 seconds. Okay, so here f is equal to 477.707 hertz second inverse, that is the frequency, and t is equal to 0.002 seconds, that is the, we have rounded it off. Okay, it will have some other thing, 0.0021 like that, so we have chosen this value, rounding it off, so it is the time period. So a very basic simple interpretation of SHM equation. Only thing what we did is we wrote the standard SHM equation in cosine form, then we compared the different values which were given in the SHM equation in the question with the standard format, and from that, using basic relationship, we calculated different values. Okay, so here is another question on simple harmonic motion, SHM equation basics. So here it is given that an object executes simple harmonic motion SHM with an amplitude of 0.17 meters. Okay, here it is in meters, and a time period of 0.84 seconds. We have to determine the frequency, the angular frequency, and write down its displacement equation, the basic SHM equation. So always the important part is writing down the SHM equation in its standard form. Here we will write it like this: A sine omega t plus phi, this. Okay, we all know A is the amplitude, omega is the angular frequency, t is the time instant, and phi is the initial phase. Here nothing has been mentioned about the initial phase, no information has been given, so we will consider the initial phase as 0 radians. Okay, that is very important. Then it has been given that the amplitude A is equal to 0.17 meters. Another information which is given is the time period capital T, which is equal to 0.84 seconds. Now we know time period is inverse or reciprocal of the frequency. That implies f is equal to 1 by t, which is equal to 1 by 0.84. So it is coming around 1.2 hertz or second impulse. So that is the frequency. Then we need the angular frequency for the SHM equation. Angular frequency is equal to 2 pi f, that is equal to 2 pi into 1.2. It is coming around 7.5. okay, 7.5. okay, this radians second. So we have got all the parameters. I think we have got omega, we have A, we have the initial phase angle which is 0 radian. So we can write the SHM equation by substituting the values here. X is equal to 0.17 sine 7.5 t plus 0, or 0.17 sine 7.5 t, this much. This is the SHM equation. We have determined the time period, from the time period, the frequency, the angular frequency, and this is the displacement equation. Okay, so a very basic thing. Okay,